Hello dear friends, welcome to Humble Mark Academy. In this video guys, we shall be looking at the correction of the physics section of the Cameroon National Qualifying Exam for Medicine for medical training. So guys, stay connected and watch the entire video. That way you're going to understand every bit of the concept we shall be doing today. Like I said guys, we shall be focusing on physics, that is from question 76 to question 83. Then later on guys, we shall continue from question 23 and we are going to finish the entire paper. So guys, before I get started, I want us to introduce ourselves. I am Omenjo Macarius guys, and this is Humble Mark Academy, where I take complex science concepts, I break them down into tiny bits. I take Concour questions, I take GCE questions guys, concepts that students find it very difficult to understand. I break it down into tiny little pieces such that any student across the globe that has any science exam or engineering exam to take can use these concepts now to score a better mark in his or her exams. Guys, I promise that I'm going to help each and every one of you to enter your dream schools, but I can only do so once you've hit that subscribe button guys. So guys, what are you waiting for? Hit the subscribe button and join my academy and let's proceed. Great. So guys, let's get started. Great friends, all right. The question 76 is saying that the SI unit of work done on an object is, these are the options they've given us. All right. So guys, let's get started. So guys, we should recall that work done is simply given as a product of the force times the distance. They want us to get the base unit of work done. Now guys, therefore means that the unit of work done, that is WD, has to be equal to the unit of force, which is the Newton, times the unit of distance, which is simply meters. Guys, keep in mind that this formula works for those who are taking ordinary level. Okay, this formula works best for those taking the ordinary level, but work done in its condensed form guys is simply the product of the force times the displacement. Keep in mind that distance and displacement are not necessarily the same. There are some cases where they are the same. In most cases they are not the same. Great. All right, so guys, but the newtons is not a base unit, right? So we have to break it further. We should keep in mind that the newtons can be expressed as the kilograms meters per second squared. Then we still have the meters in white. So we have the meter in white and the one in yellow that can give us kilogram meters squared per second squared. Great. So guys, this is our answer and it corresponds to option A. Good. So we are going to click on option A as our correct answer. So guys, if there's something you don't understand or something that is not clear guys, feel free to reach out to me in the comment section down below. I'm going to get back to you as soon as possible. All right guys, let's look at question 77, which simply reads that which of the following physical quantities are all scalars? A, weight, temperature, mass. B, weight, displacement, speed. All right, so guys, let's analyze each of the options step by step. All right, so guys, let's start. Is weight a scalar? No guys, weight is a vector. So if we see any vector in any of the options, we just eliminate it because it cannot be our answer. So option A is out. Option B, weight, the still weight guys, is out. This displacement as well is a vector, so it is out. Let's look at option C. Weight again guys, it's a vector, so it is out. Then D, force. Force is a vector guys, so it is obviously out. Displacement as well is also a vector, which is out. Velocity is a vector, which is out. So the right answer here guys is E, none of the above. Great. So that's it guys, none of the above answers are correct. All right, so friends, let's go to question 78. Question 78 is simply saying that which of the following affirmations concerning a body in motion is not correct? Great. So guys, please, before you go to any question, I would like you to pause the video and give it a try. All right guys, let's try to examine. The option A is saying that each time the speed of a body changes, its velocity also changes. Guys, is this statement true? Great guys, it is perfectly correct. Okay, it is correct. It is correct. Keep in mind that that velocity is simply what the magnitude of the speed. Velocity is speed but with direction. So guys, if the speed changes guys, the velocity obviously has to change, because what makes speed and velocity different is just that with velocity there is what is there is direction, okay, but with speed there is no direction. Great. All right, so friends, the B part is saying that if the body has a constant speed, it is possible for it to have an acceleration. Perfect, guys. It is perfectly correct. Okay, it is correct. You can take, for instance, a body that moves in a circular path at constant speed. Okay, it accelerates because the direction keeps on changing. All right. Then option C, guys, is saying that if it was brought to rest, it is not possible for it to start moving if the resultant force acting on it is null or zero. This option is correct, guys. It's correct. Option C is correct because if a body must be put into motion, guys, it therefore means that the force that causes the motion of that object must not be zero. If the force is zero, the body will keep on being at rest. But that does not mean that each time the resultant force acting on an object is zero, then the object must be at rest. No. But in this case, since the object already has been brought to rest, the resultant force that should cause the object to be in motion must not be zero. All right. Then the D part is saying that even without acceleration, it is possible for the body to change its speed. Friends, this option is not correct. Okay, it is not correct because the moment the speed of an object changes, that object accelerates. Great. So guys, obviously E, all of the above, which is wrong. So guys, the only answer here that we can take is option D. Option D is the best because each time the speed of an object changes, that object must accelerate, guys. Must accelerate. All right. Let's look at question 79. So friends, if there's something you don't understand, feel free to reach out to me in the comment section down below, guys. I look forward to answering all of your worries. Question 79 is simply saying that a block X of mass 3 kilograms is accelerated from rest by a force of 5 newtons during 2 seconds. An identical block Y is accelerated by a force of 5 newtons in 4 seconds. The ratio of the kinetic energy of X to that of Y after acceleration is... Alright, these are the options, guys. So friends, I'm going to show you guys two ways in which we can solve this same problem. Then from there now, you're going to let me know in the comment section down below which of them is your favorite. Alright, so guys, we are going to start by saying that we know that since the two blocks, since the two of them have are identical, means they have the same mass, right? And since they are being acted upon by the same force, that is 5 newtons, they are going to have the same acceleration. So now guys, therefore means that the acceleration of block X and Y from Newton's second law, we can simply say that it is simply given as what, guys? The force over the mass. The force is what? 5 newtons, and the mass, since they are identical, it is going to what? 3 kilograms. So we have 5 over 3 meters per second squared. All right. So guys, now from the law of uniformly accelerated motion, that's the equation, guys, which is simply saying that V is equal to U plus AT, where V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time taken. That therefore implies, guys, we seek to find the velocity in which these two blocks are going to attain. It therefore implies, since the equation told us that they will be accelerated from rest, it therefore means that the initial velocity has to be what? 0. It therefore implies our V now is therefore going to be A is what? 5 over 3. Then the time taken for the duration of the acceleration of the first block X is what, guys? 2 seconds, right? So we have 2 seconds. So if we do that, guys, we are going to have 10 over 3 meters per second. That's the velocity attained by block X. Now, guys, to get the velocity attained by block Y in a similar manner, we're therefore going to say our V is equal to, the acceleration is what? 5 over 3. The time is what? Is 4 seconds, as the equation gave us here, 4 seconds. So we have 4. This is going to give us answer to be what, guys? To be 20 over 3 meters per second. All right. So guys, now that we have the velocities of the two blocks and we have their masses, we can therefore go ahead now to compare their kinetic energies. It therefore implies we know that kinetic energy is given as what, guys? 1/2 mv squared. Great. It therefore implies the equation is asking us to get a ratio of the kinetic energy of X to that of Y. It therefore implies we are going to get the kinetic energy of X over the kinetic energy of Y, which is simply equal to Friends, keep in mind that 1/2 is a constant, right? Half is a constant. M, which is a mass, is also a constant. Since the two blocks are identical, means they have the same mass, so they are going to cancel off. All we need to do now is to square their velocities. If we square the velocity of x is what, 10/3, right? And since they both have a denominator of 3, when you square and divide, the nines are going to cancel. So we are going to have the square of 10, which is 100, over the square of 20, which is simply 400. When we cancel, guys, we are going to have 1/4, right? Which is simply going to be what, guys? The ratio is simply going to be 1:4. Wait. So, guys, option C is good, right? Option C is good. But, friends, I want to show you guys another method. Then you're going to tell me which of the methods, which of these methods is your favorite. Which of them are you going to adopt? All right, let's look at method 2, guys. In method 2, guys, we are going to be examining the work energy theorem, because we are going to be using the work energy theorem, guys, which simply tells us that the change in kinetic energy of a body is equal to what, guys? The work done by the net force squared. This is according to the work energy theorem, which states that the change in kinetic energy of a body is equal to the work done by the net force. It therefore implies, guys, that in this case now, we seek to get the displacement of each of the blocks. Keep in mind that they have the same acceleration, they have the same mass, they are being acted upon by the same force, but the duration in which the force is acting is different. So we are going to get now the displacement. We are going to be using the equation S equal to ut plus 1/2 at squared. It therefore implies, guys, the distance covered by block X is therefore going to be, since they both started from rest, means U is 0. So we are going to have our Sx to be the same like 1/2. Acceleration, we got here to what, guys? 5/3. The time taken, the time is 2. If you square that, we have 4. Right? Good. So, guys, let's say this is our displacement. Then, guys, now the distance covered by blocks Y similarly is going to be what? 1/2. A is 5/3. The time is what? 4 seconds. So if you square that, guys, we are going to have what? Great, 1/16. So it therefore implies, guys, that we know that what, guys, that work done is simply equal to what, guys? Force times the distance, right? Since the work energy theorem simply says that the change in kinetic energy of a body is equal to what? The work done is equal to the work done by the net force. And kinetic energy, guys, the change in kinetic energy simply means what, guys? Final minus initial, right? Since the initial is 0, because the both started from rest, initial is 0, so we are just dealing now with the final kinetic energies. As such, guys, we are therefore going to having that the ratio of the kinetic energy of block X over that of Y is simply equal to, in this case, guys, since it is force times distance, the force is a constant, right? They have the same force, so we can just neglect that. All we need to do now is to take the distance of X and divide by the distance of Y. We have 1/2. You can cancel this 1/2, right? 5/3 as well can cancel. So we are just going to be looking at just 4/16. And this is going to give us what? 1:4. Great. So, guys, let me know in the comment section down below, guys, which of this method is the best for you. Which of them is easy. Okay, which of them is easy. And if you don't understand, guys, let me know in the comment section down below. I'm going to get back to you as soon as possible. All right, guys, let's move on to the next question. Okay, friends, let's look at question 80. It's saying that since an electron carries a charge of 1.6 times 10 raised to the power negative 19 coulombs, how many electrons per second across a conductor when it carries a current of 1.00 milliamperes? All right. So, guys, the clue to this question is that they want us to calculate how many electrons per second. That is N/T. All right. So, friends, to tackle this question, first of all, I want you to pause the video and give it a try, guys. Okay, pause and give it a try. Then unpause it now to check the solution. So, guys, we are going to examine one of the powerful formula we know in electrostatics, which simply says that The charge is equal to what, guys? Ne, where this n is the number of free electrons, E is the elementary charge of an electron, and Q is simply equal to what, the charge in which we are interested in. It therefore implies, guys, in this case, we also know that our Q is equal to what, guys? IT. So now, since Q is equal to Ne and this same Q is equal to what, IT, we can therefore say that our Ne is equal to what, guys? IT. In this case now, since they want us to look for the number of electrons per second, it therefore means it is equal to what, guys? N over T. So if we make N over T the subject, we're going to have N over T equal to I over E. Our I is what, guys? 1.0 milliamperes. Our E is what? 1.6 10 raised to the power negative 19 coulombs. So if we plug in everything, guys, we are going to have 1, since milli means 10 raised to the power negative 3, so we have 1 times 10 raised to the power negative 3 over this. So guys, if we punch that somewhere, guys, we are going to have an answer to be 6.25 times 10 raised to the power 15. Great. So guys, which answer is correct? Great. Option B is correct, right? Option B is correct. So we can just simply click our option B. Great. So guys, don't forget to like the video, guys. Give it a thumbs up. Subscribe to the channel, guys, if you want more great contents. And friends, let's look at question 81. It's simply saying that the length per unit resistance of a copper wire has a value of 7.63 millimeters per ohm with a diameter of 1.450 millimeters. This corresponds to a resistivity of, alright. So guys, this question is very tricky, okay? It's very tricky. It's very tricky. So stay tuned, guys. Let's break it down. Alright. So guys, we should know that the resistivity of a copper wire or of any wire with a uniform cross-sectional area, guys, is simply given as rho, which the resistivity equal to what, the resistance of that wire times the cross-sectional area over the original length of that wire. Wait, it therefore implies, guys, that they're talking about what, guys? They talked about what? About the length per unit resistance. So we have to try as much as possible to get the length per unit resistance. So in this case, if we make L over A the subject, that is by dividing all through by R and inverting, we are going to have our A over rho equal to what? L over R, because the question talks about what, guys? The length per unit resistance. So we have length over resistance. Great. This is what we have, guys, and it's the same as what, guys? As A over rho. L over R, we have its value, right? We have its value, and its value is what, guys? 7.63 millimeters per ohm. Keep in mind that the above options here are in standard units, so we have to change all of these units now to their standard forms. Great. It therefore implies, guys, at this point now, we are going to make our rho the subject by simply saying that our rho is equal to what? R, L times A. Keep in mind that L over R, we know it was 7 point this, right? It therefore means that R over L has to be what, guys? 1 over this value. Great. So guys, let's not forget that our area is what? The cross-sectional area. And for a copper wire whose cross-sectional area is uniform, the area of that copper wire is simply given as what, guys? Pi times diameter squared over 4. Great. So we are going to have our rho to be, we have R over L, which is this in white. Then the area is what, guys? Pi times d squared over 4. Great. It therefore implies, guys, at this point now, if we plug in everything, since we have the diameter of the wire, which has been given as 1.4545 millimeters, we can change that to meters. Pi is a constant. Length over resistance is what we know, right? But in this case, we have resistance over length. So if we want length over resistance, we have to combine these two, guys, and put it in this denominator. So if we do that and plug in all our values, we are going to have rho to be the same like pi over 4 into, we plug in everything. The diameter is what, guys? Is 1.45 millimeters. If we put that to meters, we are going to have 1.45 times 10 raised to the power negative 3, right? Since the squared, everything has to be squared. Then R is up, L is down. If we want to have but L over R, we have to bring it down, right? which is simply going to be 7.63 times 10 raised to the power negative 3. Since they gave us in millimeters, we have to put that to meters by multiplying by 10 raised to the power negative 3 meters per ohm. So guys, if you plug that into your calculator and punch, you're going to have an answer to be 2.16 times 10 raised to the power negative 3 ohm meters. Great. So guys, which option is correct? Great, option A, right? So we can click on option A as the correct answer. Great. All right. So guys, let's look at the next question. Let's look at question 82. Right. Great. Here is it, friends. Let's look at question 82. It's saying that an ideal gas dilates in an isothermal manner and absorbs a quantity of thermal energy equal to 500 joules. The amount of work done during the expansion is, these are the options, guys. All right. So guys, the key to this question is what? Isothermal manner. Okay, isothermal. Keep in mind that in an isothermal process, the change in temperature is what? 0. Okay, it is simply a process that occurs at constant temperature. As such, there is no change in temperature. Consequently, guys, the heat that is being transferred into that system is what? 0. As such, guys, if we know from the first law of thermodynamics, which simply says that delta Q is equal to what, guys? Delta U plus delta W, which this delta Q is simply the heat supplied to the system. Delta U is simply what, guys? The change in internal energy. Delta W is what, guys? Is the work done on the gas or by the gas. Great. It therefore means that at this point in time, guys, for an isothermal process, we know that it occurs at constant temperature, right? It therefore means that delta Q is equal to what? 0. As such, it therefore means that our delta W now simply becomes what, guys? Negative of delta U. Our delta U is simply what, guys? The energy absorbed, which is what? The change in internal energy. So when we do that, guys, we are going to have an answer to be what, guys? To be negative 500. So the right option here is option D. Great. So friends, if there's something you don't understand, like I said, let me know in the comment section down below, guys. I'm going to get back to you as soon as possible. Great. All right. So the question 83, which I believe is the last, it's saying that it's a sample of a gas of volume 1.5 times 10 raised to the power 5 meters cubed at a pressure of 3 times 10 raised to the power 10 Pascal. What is the new volume when the pressure is reduced by half at constant temperature? Great. All right. So guys, all we need to do in this case is to use Boyle's law, since Boyle's law tries to relate the pressure and the volume at constant temperature. So the Boyle's law simply tries to relate, it simply tries to tell us the inverse relationship that exists between the pressure and the volume when the temperature is kept constant. So guys, to proceed in this question so well, we are going to be using the Boyle's law. Like I said, according to Boyle's law, guys, it simply tells us that the pressure is inversely proportional to what, guys? The volume. This statement simply means that, guys, that the pressure times the volume has to be what? A constant. Wait. In this case, guys, it is simply trying to tell us that P1 V1 is the same like what, guys? P2 V2. This is what this statement means. This is what the statement means, that P1 V1 is the same like P2 V2. But what the equation tells us, guys, that they want us to get a new volume when the pressure is reduced by 1/2, right? It therefore means that we need to solve for V2 in this case. If we make V2 the subject, we are going to have V2 to be the same like P1 V1 over P2. But we are being told that well, the pressure is reduced by 1/2, right? So it therefore means that this P2 has what, guys? Half of P1. So we are therefore going to have our P2 to be the same like what, guys? Half P1, right? So if we plug this back into this equation, guys, we are therefore going to have our V2 to be the same like P1 V1 over what? A half of P1. But this P1 up, right? You can cancel it with the one we have down. So we are going to have and we have 1/2 down, it can go up as 2. So we have our V2, which is the same like what, guys? 2V1. It therefore implies at this point now, guys, our V1 is equal to what? Is equal to 1.5, right, times 10 raised to the power 3. So if we multiply this by 2, we are going to have an answer of 3 times 10 raised to the power 3 meters cubed. So guys, the right option here is what? Option what? Wait, I'm sure it's option C, right? Great. So we can come here and just mark our option C as the correct answer. Great. So friends, that's it for our video. That's it, guys. I hope you found it useful, guys. If you found it useful, like I said, guys, hit that subscribe button so that you're going to have all latest updates about the contents we produce here, guys. We produce contents in this channel, guys, every day of the week, guys, every day, and you can only have access to those contents once you've subscribed to our channel. And friends, have a blessed day and good luck as you prepare for your exams. Those writing NAPI exams, stay tuned in this channel. Get yourself subscribed because we are going to be uploading so many contents every day. We can upload about 5 contents a day, so keep an eye on the channel. Have a blessed day.